Hi guys, we are looking at the cubic graph here, given that h of x is equals to negative x cubed plus ax squared plus bx, and g of x equals to 12. P and Q are the turning points of h. P and Q are the turning points of the graph of h, and the graph of h passes through the origin. Okay, so 1.1 show that a equals to 3 over 2 and b equals to positive 6. Okay, let us do that. Okay, so what do we know about this equation? That what we know is that q, coordinate of q, 2 and 10, is on the graph of h, is the turning point of h, right? So we can use that to substitute there. So we can substitute q here on the graph of h. So I'm going to do that. The y value is 10, right? The y value is 10, plus 10 equals to negative into x cubed. X is 2 plus ax, a into x is 2, ax squared plus bx, x is 2. Okay, I substituted the coordinate of q, substituted q. So I'll write here sub q, q. Okay, so that is what I did. I substituted h, q, the coordinate of q, into the graph of h, right? Okay, so let me simplify it further. So this is 10 equals to negative 8 plus 4a plus 2. Okay, so this, call this equation 1. I'll call that equation 1. Okay, so I have equation 1 because I have two unknowns. So once I see that I have two unknowns, it means I need another equation so that I can have equations and two unknowns, and then I can solve them. When you have two unknowns, you need two equations to be able to solve the unknowns. Okay, what else do I know about the graph? I know that the gradient of the graph h prime, gradient of the graph is equals to 0 at the turning point, right? And then we know the x values, we know the x value of turning point, and the x value of the turning point is what? It's 2, because we are told that the graph, we are told that the P and Q are the turning points. So we know the x coordinate of the turning point. I'll say and x equals to 2. X equals to 2 at the turning. Okay, so I'm gonna write I'm gonna derive the graph and equate it to 0, because we know that at the turning point the gradient is 0. Okay, that was covered on part 1 graph. So when we derive this, have what? Minus 3x, say minus 3x squared, right, plus 2ax plus b plus b. We derive that equation, right, and then we equate this to 0. Okay, equate this to 0. So it means when you derive the equation and you substitute the x value for the turning point, you should be able to get 0 because the gradient is 0. Remember that we have proved that when you derive an equation once for finding the equation of the gradient, we proved that with the first principle on part 1 of cubic graph. Okay, so here we know the x value that should make this 0 because the x value is the x value of the turning point, and we know the x value of the turning point is 2. Wrote it here. So it means when you substitute 2 here, the gradient becomes 0. So we can substitute 2. Okay, so equals to negative 3, 2, but 2 into 2 a plus b. This equals to 0 because this is the gradient at the turning point. Okay, so I will simplify this. When I simplify this, it becomes 12. Okay, 12 for a plus b equals to 0. All right. So this is equation 2, but let me make b the subject because b here it's the coefficient of b is 1. So I'm making b the subject so that I can substitute in equation. Okay, I'm gonna say b is equals to 12 minus 4a because b is positive, so I'm gonna take 12 to this side. It's gonna become it was negative, it becomes positive, and when I take 4 from this side to this side, it becomes negative. Okay, so this I'm going to call equation. Right. So now that I have equation 1 and equation 2, what I'm going to do now is I'm going to substitute. Okay, come here and say substitute sub equation 2 into equation 1. Okay, I'm substituting b into equation 1. So in equation 1, what do I have? I have 10 equals to minus 8 minus 8 plus 4a plus 2b, right, plus 2b. But what is b? b is 12 minus 4a, is 12 minus 4a. Okay, I substituted, so from here I will just simplify and solve for a because the only unknown is a. I have only one variable here, so I will solve for a from here. So when you solve for a here, to simplify, gonna be okay, let me expand this, gonna be that 10 equals to negative 8 plus 4a plus 2 multiplied by 12 is 24. That is going to be 24, and 2 multiplied by negative 4a is going to be negative 8a. Okay, when I simplify further here, negative 8 plus 24, that becomes negative 16, it becomes positive 16. Positive 16, when I take it to the other side, is going to be 10 minus 16 is going to be negative 6. Okay, be negative 6 equals to 4, positive 4 minus 8a, this becomes minus 4a. Okay, so I divide both sides by negative 4, a comes, this is the same as a is 6 divided by 4, because they are both negative, the negative cancel out. When I simplify this, a becomes they are both divisible by 2, so 6 divided by 2 is 3, and 4 divided by 2 is 2. So a is 3 over 2. We have cut. Okay, cut. Okay, and now you need b, right? So we already have the equation of here. You'll just substitute a into equation 2. Okay, so just substitute a equal equation 2. Just say b equals to 12 minus 4a. 12 minus 4a. A is 3 divided by 2. Okay, so when you simplify that, 12 times 3, 4 times 3 is 12 divided by 2 is 6. So this is the same as 6 minus 6. Same as 6 minus 6. So this is the same as 12 minus 6, because this is 4 times 3 is 12. 12 divided by 2 is 6. So this is 12 minus 6. Therefore, b equals to 6. Given. Okay. So we have the value of we have the values for a and for b. Of a, and we have the value of b. So shown what they asked us to show. Okay. Shown what asked us to show. Okay. So let us go to the next question. Okay. The next question, they say find the x values for the x-intercept. So we need to find the x values for the x-intercept of the graph of h. Okay. So the equation, this one, of h is this one. Okay. Equation of h is that one. What I'm gonna do, I'm gonna write it here. It's there. Substitute equation there. Then, because now I know the value of a and I know the value of b, so I'm gonna substitute. Where I see a, I'm gonna write 3 divided by 2, and let me put it in brackets. Where I see b, I'm gonna write 6, because now I have them. Right now they are saying write the x values for the x-intercept. So we know that the x-intercept is the x value that when you substitute in the equation gives you 0 for the y value. So from this we can see all the terms are multiplied by x. All the terms here on this, they have x. So meaning if I make x 0, then h becomes 0. So the y value becomes 0. So this means that x equals to 0 is a factor, right? X equals to 0 is a factor. Okay, let's say x equals to 0 is a factor. It's a factor. Okay, so or others might just say in bracket x minus 0. This minus 0 is a factor like that. Okay, then now that I have one factor, I can find the others. So I'll take x out as a common factor. If I take x out of the common factor, I'll say x into, when I take out x out as a common factor, I remain with x. I remain with x squared, right, plus 3 over 2 multiplied by x. Here I will remain with 1x because I've taken 1 out, plus 6. Okay, so when I take x out, I remain with this. So, and x, I know the value of x is a factor, so here I'm factorizing. So now I'm left with this part, left with this part, the quadratic part, to solve. So for that, I used the quadratic equation. For that, I used the quadratic equation. I believe we know how to use the quadratic equation. So I just came here, x equals to, came here, said minus b, b is 3 over 2, okay, plus or minus root of b squared 3 over 2, but minus 4 into AC. A is negative. A is negative. It's quadratic part. And to C. C is positive 6. Okay. All over 2A. A is negative 1. There. So when I do this, I get x equals to 3 plus or minus the root of 105 plus or minus the root of 105 all over 4. Okay, all over 4. So now means the factors here. When I simplify this further to get the factors, have x equals to 0 from the quadratic equation here, x equals to negative 1.81, right, and negative 1.81, and x equals to 3.31. Okay, so these are the x values for the x-intercept of this equation. Okay, so this is the solution they want. This is the solution. This is the thing they are looking for. Okay, so we solved that. Let us go to the next one. So here the next between P and Q, between P and Q, if it is given that x equals to negative 1 at P, so the x value for the coordinate P is 1. So now that we know the x value for P, let's find the y value for P, and then we will use point P and Q to find the average gradient. Okay, let us do that. Let us do that. We know the x value, so we can substitute and get the y value. Okay, I'm gonna write here and say take the equation of h, and on the equation of h I'm gonna substitute the x value being negative 1. Okay, to find the value. So say h at negative 1 equals to, so this means the x value, x is negative 1, x is, so I want the, okay, I'll say negative 1, say negative into negative 1 plus 3 over into negative 1 squared plus 6 to negative 1. Okay, so the y value is equals to, when you punch this on your calculator, it gives you negative 7 over 7, that is 3.5. It's negative 3.5. Okay, so this means this actually means coordinate of is negative 1, negative 1, negative 3.5. Okay, so this is the coordinate of P. The coordinate of 2 we have it, coordinate of 2 is, coordinate of 2 we have it is 2 we are given, set 2 and 10, that was given. Okay, so let us use this to get the average gradient. How do we get the average gradient? So, well, we know that gradient subscript in on P, right? It's gonna be what, changing y over x, meaning is P gonna be y at 2, y at all divided by x at 2, x at 2, x at p, right? That's at okay. So that so y at 2, y value at is 10 minus the y value at negative 3, 3.5, right? All divided by the x value at q is 2 minus the x value at negative 1. Okay, so the gradient m equals to, when you calculate the gradient here, then subtract, this is to be negative 12.5, so this is going to be 13.5 divided by 3, 5 divided by 3, and it gives us gradient of 4.5, 4.5. Very nice. That's the gradient of 4.5. So the gradient is 4.5. Okay, 4,5 or 9 over 2. 4,5 or 2. Okay, that is the average gradient in point P and Q. Okay, let us look at the next question. Okay, so here they are saying show that the concavity of H changes at x equals to half. Okay, on the previous lesson I explained that when you're talking about the concavity, you're talking about a point where the graph changes from concave up, concave down, or from concave down to concave up. So at that point where the graph changes the concavity, I said you get that by doing two derivatives. For the second derivative equals to 0. You equate the second derivative to 0 and solve for that value of x there. Okay, let's do that. So we'll start by the first derivative. So the first derivative equals to, we've derived this once. Said first derivative is minus 3 x z, okay, plus a. When you derive this, that when you derive this, you say 3 times 1 is 3x, then 3 minus 1 is 2, so negative 3x squared. Then when you come to the second part, because now we know the value of a, so a is 3 over 2, so when you say 2 times 3 over 2 cancels 2, you remain with 3. It's going to be 3x, and 2 minus 1 is 1. Okay, then b is 6x here, 6x. When you derive 6x, you remain only with 6. Okay, so that is the first derivative for this part, right? But for the concavity part, you need to do the second derivative. So the second derivative will be what? That second derivative to x equals to and derive it again, multiply negative 3, gonna be negative 6x minus 1 is 1, with that, plus 3x 3, 6 0. Okay. So now this is the second derivative. You equate the second derivative to 0. You equate the second derivative 0. Okay. So this means that second derivative here x is equals to 0. Okay. Now this tells us that negative 6x plus 3 equals to 0. We equate this second derivative 0 and you solve for x. Okay. So from here I will take 3 to the right side, when you 3 to this side it's negative. So this means you will be 6x equals to 3. When you divide both sides by negative 6, remain with what? Remain with 3 over 6. 3 over 6, they are both divisible by 3. 3 goes once to 3, 3 goes twice into 6. So x equals to 1 over 2. So we have proved that concavity of the graph changes at the point x equals to 2. Right. So there, proved that part. Let's go to the next one. Okay. So the next one they're saying explain the significance of the change in question 1.3. Okay, there's a mistake. This is question 1.4. Okay, explain the significance of change in question 1.4. Explain the significance of change for that concavity there. What does that tell us? Okay, that tells us that that point is a point of uh, inflection. That point there, x equals to half, is the point of inflection. Okay, where the graph changes shape from concave up, concave down, or from concave down to concave up. So here I'm going to say x equals to 1 over 2 is point of inflection. Point of inflection. Okay, so that is the significance of that value that we got on 1.4. Okay, that is h of x, where x is negative 2. Find the tangent to the graph of h, where x is negative. Okay, so if you have a graph like this, right? If you have a graph like this, so say negative here, get tangent to the graph. Okay, that is actually not accurate. Up is up, will have tangent, a line touching the graph once. So let's say that point is somewhere here. So find the coordinate of y on the graph when x, and then we derive the graph equation to get the gradient. Okay, so let us do that. So here we have the equation. I'm gonna write the equation of h, gonna be h, so that is h x equals to minus x plus 3 over 2 x squared plus 6x. Okay, plus 6x, like that. And now what I'm gonna do here is, now I'm gonna find h when x is negative. So this will be this again on 2 also. Okay, so h equals to negative h multiplied by negative h is positive 4 multiplied by 3 is 12 by 6. So uh, plus 6, it's 14. It's gonna be negative 12. So 14 minus 12 gonna be 10. So the coordinate here is going to be what? Coordinate is going to be negative and negative 2. Okay, so now we have the coordinate. Let us find the gradient so that we remember a tangent is a line that touches the graph of once. It's a straight line, right? So let us find the gradient. So we're going to derive equation of h. We're going to derive equation of h so that we find the derivative. Okay, let us do that. Let us find the derivative of h. So the derivative equals to minus multiply by negative 1, 3x squared. Okay, by 3 over 2 plus sorry, x plus 6. Okay, now that we have the definition of the gradient, so this is the variable done. I messed up the in. So now that we have this, I'm gonna so now that we have the gradient, find the gradient x. Okay, the gradient equals to 4 multiplied by raised negative 12. This is negative 6 plus 6 will cancel out, so the gradient is negative 12. The gradient is 12. So now I have coordinate and I have the gradient, so I can find this line. So I'm gonna do it here. Y equals to mx plus c, and I will substitute that coordinate. So y equals gradient 12, okay, multiplied by x is plus c. So by simplification, this is be positive 4 when you the other side minus 4. Okay, so it's gonna be 20. So c plus, therefore equation of the tangent equals negative 12 x minus a. So you can test it by substituting the coordinate y. X is negative 12, 2, negative 4. 4 minus 2, the checks out. So this is the equation of tangent graph of h. The graph of h. Let us go to 1.7. 1.7. Here they say determine the value of x when that x is less than 0, at which the tangent to h at which the tangent to h is parallel to e. Okay, at which the tangent to h is parallel to e. Okay, so what is the tangent, the gradient of g? We need to know. Parallel lines have the same gradient, so the tangent of h will have the same gradient as the graph of g, and the graph of g has a gradient of 12. No, in fact there's a mistake. This is supposed to be negative 12. So when I was copying this down, made a mistake of leaving the negative there. That is negative 12. Okay, so made a mistake of leaving the negative. Okay, because if it is positive, when you solve it, it will not work out. In the end, it will say yes, there are no solutions. So see that, so it has to be negative. All right, so parallel lines have the same gradient. Okay, parallel lines same. Okay, so this means the gradient of g, the gradient of tangent, m of tangent, m of the tangent equals to m of the graph of g, m of the graph of g, okay, x, and m of the graph of g of x is what? Negative 12. Negative 12. G is a straight line, we can see there. It's written in the form of, this is y equals to mx plus c. C is 0, why there's no term for c. And because they are saying the tangent has to be parallel to g, therefore that means the gradient is the same. Parallel lines have the same gradient. Okay. So now we know the gradient of the tangent. Okay. And how do we find the gradient of a point on an equation? On the equation of h, we first derive the equation once. Find the equation of the gradient. Remember, when you derive an equation once, it results in the equation of the gradient. And we already have the gradient value, so we'll just equate it 2 and solve for x. Okay, so let us do that. So the derivative of h is equals to negative 3. We had already done the derivative in the previous questions, so that's why it's easier for me to just write it down. 3x squared plus 3x 6. Okay, so this is the derivative, and I'm saying this equation at a certain value of x, it has to give us the gradient equals to 12, or it has to equals to 12. So I know that the gradient is 12, but I do not know at what x. So I'm going to sub-equate it to 12 so that I find the value of x on the graph of h. Okay, so this is what I'm going to do. This here, so that put it here, but this is negative, and I'm equating the gradient of, I already know the gradient of tangent. It is parallel to the graph of t, so I'll say negative 12. Okay, so also here, let's copy this, same one. Now transpose this negative to the side and becomes positive 12. The positive 12 equals to 0. From here, 12 plus 6 is 18. 12. Okay. Now this becomes 18 equals to 0. So I can see that all these terms are divisible by 3. This is 3, this is, so they are all divisible by 3. Okay, so I'm going to divide everything by 3 in with x squared. So I'm dividing by negative 3 minus 1 minus x, and 18 divided by negative 3 is 6. Yeah, equals to 0. Okay. What I'm gonna do here, I'm gonna factorize. I'm gonna write here because when I multiply they will give me negative 6, but when I add them they will give me negative 1 for the middle term, right? That part I've already covered on my previous lessons when I was teaching you guys how to solve for x. So if you forgot, go back, watch the tutorials and revise. Okay, this is x and put the x equals to 0. Okay, so the factors of 6 is what? Is 3 and 2. 3 and the bigger will take the sign of the middle term, so 3 will take negative. Okay, so this will be negative 3. Okay, negative 3 times 2 is negative 6. Negative 3 plus is negative. Okay, so simplifying there. For x equals to negative 2, x is not equals to 3. Okay, x is not equals to, so in this one. Okay, why am I taking the negative answer? Because they said x is less than 0, given that x is 0. So they told us that the solution has to be the negative 1. Okay, so let's see. So x is not equals to the solution. So right. So that is the solution for this part. Okay. So watch this, practice, practice, practice until you get it right. Watch it many times and write it out. Then you can ask questions on how to solve question.